Hello, welcome back to my statistics class. Today we're going to have more examples about how to calculate discrete random variables. So this table below describes the number of repair calls that an appliance repair shop may receive during an hour. So now let's take a look. Okay, so these we don't know. So what would that be? What would be the probability of repairing will receive 3 repair call? So remember, the sum of all the probability should equals to 1. So that means we should have 0.1 plus 0.3 plus 0.4 plus whatever that number is equals to 1. So we calculate that by subtracting 0.1 on both sides, subtracting 0.3 on both sides, subtracting 0.4 on both sides. So we have, this is 0.2. So the probability of receiving 3 calls equals to 0.2, which is 20%. So how many calls should the shop expect per hour, including unit on all means? So now let's take a look. Remember how to find the expected value, or mean, or average. So expected value equals to the sum of each random variable times the probability of the random variable, such as S1 times P1 plus X2 times probability of X2 plus S3 times probability of X3, not X4, plus X4 times probability of X4. Okay, so remember the last time I did use a Google Calculator and then I end up have some typos. So this time I'm going to change the method, which is using our spreadsheet. Okay, so I already put all the numbers, put the table in it. So the first step is we want to add all of this number. Okay, so in here we want to calculate S times P of X. How to do it? So this is equals to this one times this one equals to 0, and then we drag them down. Then they will have the same formula, which is, look, if you're not sure, you can click on this slot and check. This is equal to C1 times C2, which is this one times this one. Okay, so what's the expected value? Expected value is equal to the sum of all of the random variable times the probability of the random variable. So we need to calculate the sum. So we have the function of sum equals to A3 to U3, which is 1.7. So we write 1.7 onto our chart. So we're expecting 1.7 calls. You can write 2 calls if you want to round up to the whole number. Okay, so what's the standard deviation? So remember the standard deviation. So standard deviation is equal to the square root of the variance. So how do I find the variance? Variance equals to the sum of hx minus mu. Mu is what? The expected value. And then square it and times the probability. In this case, we have 0 minus 1.7 squared times 0.1 at 1 minus 1.7 squared times 0.3 at 2 minus 1.7 squared times 0.4 at 3 minus 1.7, then we square it times 0.2. Now let's use our spreadsheet to do it. Okay, so now we found the expected value. So the next step is we want to use each number x to subtract the mu, which is our 1.7 So now let's do it. Each number we have 0 minus, which is equal to 0 minus 1.7. And then we can jack them down. It should show you the same. Look, you have C1, which is this number, the number of repair call, minus 1.7. Okay, so what's next? The next is we want to square them. So we let it equals to this slot and then square them. Oops. So now look, every number is equal to C4, which is the x minus the average value, and then we square them. Okay, so what's next? After you square them, you want to times their probability. Okay, so basically is you want this number multiply the probability 0.1. And then we'll repeat these. Oops. You drag the little square. Oops. My cursor is too big. Oops, doesn't work. Okay. So after time, like, what's next? The next should be you try to sum all of these, right? Yes, they already automatically tells you that, hey, sum B6 to B. Yes. So this is what? This is going to be our variance. And then how to find the standard variance? The standard deviation equal to square root of the value, which is here. So we have 0.9. Okay. So I know that you can do it on the spreadsheet, but I want you to try to show me the stat, how you use the formula, and then calculate that. The standard deviation is equal to 0.9. So now D is asking you what's the probability that they got 2 repair call. So the probability of they got 2 repair call equals to, look at the chart or the table, is 0.4. So, I forgot to mention that since this is a call, you can try to round them up 2 calls and round them up. This is 1 call, variance to 1 call. Okay, so now continue. What's the probability that they got at least 1 repair call? So that means x greater than or equals to 1. How many probability that they got at least 1 repair call? They might got 1 call, they might got 2 call, or they might got 3 calls. So totally the probability is 0.9. So what's the probability they got at most 2 repair call? Well, at most 2 repair call means when x less than or equals to 2. So then we have when they got no call, they got 1 call, and the probability when they got 2 call. Oops, sorry. So we have 0.1 plus 0.3 plus 0.4 equals to 0.8. Okay, what probability that they got less than 2 repair class? They want to say call, 2 repair calls. Okay, less than. That means it's not equal to. So there's 2 probability. Either they got no calls or they only got 1 repair call. Okay, not including 2 because it's less than. So this is equal to 0.1 plus 0.3 equals to 0.4. Okay, now let's take a look at another example. So they say if you roll a die, if it comes up at 6, you win 100. If it's not, you got to roll again. If you get 6 the second time, you win 50. If it's not, you lose. So what's the probability? So let S be the amount that you might win in dollar. Okay, so now let's create a discrete variable discrete random variable table. So we have x and then the probability. So now think about it. You have the chance to win $100 or $50, or you lose, not lose, you didn't win anything. They didn't mention about that you lose. So if you roll a die, think about you have a die. It came up with 6. So what's the probability that when you roll a die and then you got 6? It's 1/6, right? So now the second one is what's the scenario that you will win $50? Is you roll a die, you didn't get 6 the first time, but you roll it again, you got 6. So that means the first time when you roll the die, you can get 1, 2, 3, 4, 5, but not 6. Not 6. And then multiply the probability that you roll a die and got 6. So what's the probability that you didn't get 6? Which is 0.6, 5/6 times the probability that you would get 6 on the second time, which is 1/6. So when you multiply these two together, would be 5/36. That's the probability that when you roll the die twice, the first time you didn't get 6, but the second time you got a 6. Okay. So what's the probability that you got no money? Remember, the sum of the probability equals to 1. So that means if we add 1/6 plus 5/36 plus whatever this probability is should equals 1. And then we do the calculation. This part equals to 25/36. Okay, find the expected amount that you will win. Again, we're going to use our spreadsheet. Okay, so expected value, how to calculate expected value? Expected value is mu equals to 100 times 1/6 plus 50 times 5/36 plus 0 times 25/36. Let's use our spreadsheet. So I already put in the number here. So this time I'm going to change the location a little bit. Okay, so what we want to do is we want these two equals to 100 times 1/6. Hold on, why this is equal to 1/10? That made no sense. This should be 100/6. Oh, this is that's the date. No, that's not the date. I'm sorry. That's 1/6. 1/6. No, this is 1/6. Oh, so now there's a problem occurred. You might notice that. So now let's take a look. This, when you type in 1/6, instead of consider it's 1/6, now it's considered what? It's a date. It's January the 6th, 2022. But we don't want the data as a date. We want it as a fraction. So what we're going to do is, I'm going to show you another way to do that. Insert a row above. Let's put this again. Instead of 1/6, we put as a function, use 1 divided by 6. Similarly here, not just 5/26 is equal to 5 divided by 36. Similar in here, we put an equal sign. So now the data should work. Now let's continue our expectation value. Let me delete this row. Okay, so expected value equals to what? The sum of x times p of x, right? So that's equals to this number times this number, and then autofill. But this is not done. We still need to find the sum, because the sum should be our expected value. Expected value, or mu. Sometimes they say mu. equals to the expected value equals to the sum of this function. Okay, so our expected value is 23.611111. So now let's write this down. That's how much you expected to win, right? Okay, so find the standard deviation. Remember, the standard deviation is equals to the square root of the sigma square, which is the variance. So now let's do it. So equals to 100 minus 2361 squared times 1/6 at 50 minus 2361 squared times 536 plus 0 minus 23.61 squared times 2536, and then take the square root of the whole thing. Again, let's use the spreadsheet to do it. Okay, so after we found mu, the next thing we want to do is we use the random variable to subtract the mu. So we have equals to 100 subtract 23 subtract this number. Okay, and then this one they can autofill, so let's do it by our hand. This number subtract our mu. Also, this one equals to this 0 subtract our mu. Okay, so the next thing is we want to square them. So how to do it is equals to this number square. This one we can do autofill. And then what's next? After you square them, you still need to multiply the probability. So let's multiply the probability. So we have this number. Did I do this right? Let me check. Oh, this is not just equals to D10. This equals to X. Oh yeah, that's correct. Okay, this equals to E times our probability in here. Oh, no, sorry, times this one. And then now autofill. Okay, and then we add the sum to find out what's the variance, which is also called sigma, equals to the sum of these three numbers, add them up together. And then that's not our standard deviation. Standard deviation is we take the square root of the variance. So the standard deviation is 37 and 89, and then we round it up to 2 decimals, so it should be 37.9. Okay, let me write that on the iPad. Oh. So that makes sense, right? Because you either winning 150 and 0, so the variance is going to be big. Okay, so should you play the game if it costs $25? Why or why not? Definitely no, because in the long run, you're going to lose your money. Because the expected value, in the long run, that means you play multiple times, you are expected to win $23.61. No, because the expected value is 23.61. In the long run, that means you're going to losing $1 something, right? That's why we don't go to casino. That's why I say statistics is really powerful. You can calculate the expected value to see, hey, should you play that game or not? Okay, what cost to play and would it make the game fair? If you wanted to fair, the cost should be $23.61. Okay, so that's it for today. Today we learned something really useful and that we're going to use it on our day-to-day life. I'll see you next time.